For this lesson, we're going to cover the concept of improper integrals. And you'll see this has a 3-point question mark because it's not covered in your book, but it is something we need to cover in this class. So here we go. This is your only means of lecture, so please make sure you watch the video. Okay, so the first thing, really the only part to this lesson you don't already know is just the meaning of the concept, or meaning of the word converge versus diverge. And converge is a very simple concept. It just means that your limit approaches a number. So when I say approaches a number, what I mean is like literally 4 or 10 or 1/2 or -1/3. Okay, converge means to approach a number, where diverge means to approach infinity. Okay, so if you think about what that's saying graphically, what we're saying is if you have a limit, at, let's say we're testing 4, it means your graph's going towards some number at 4. It's approaching a number. That would be the concept of converge. It's going towards something. To converge on something means you're going towards it. To diverge means, like maybe at the number 4, we had a vertical asymptote. So your graph's going towards infinity, or maybe towards negative infinity. So that's the concept of converge versus diverge. You have those. That's the only new thing. Okay, so a lot of after a lot of the problems, we're going to say, does it converge or diverge? Or a homework problem might ask you, does it converge or diverge? So you just got to answer those questions. Now, the rest of this lesson is just going to be a combination of things you already know. The first thing that we need to refresh is limits. So the basic idea from limits was if we could substitute in the number, that's all we needed to do, and we were done, as long as the graph was continuous at that value. So in this case, 1 over x, it's continuous at 4, and I'm able to substitute that in and give me the value of 1/4, which would tell me for this graph of 1 over x, which looks something like this, at the value of 4, my graph is approaching the y value of 1/4. And I would say it is converging because it's going towards a number. Okay, next one, infinity. So now, remember, we're not allowed to substitute infinities. But what we did do is we just wrote it's over something really, really big. So in 1 over something really, really big, one piece of bread divided amongst everybody on Earth, that means everybody is getting 0. So once again, when you look at that graph, as x approaches infinity, our graph is approaching 0. And since it's approaching a number, we're going to say it converges once again. So hopefully you're remembering this review. This is just all from way back in chapter 2-ish. So same graph, but now we're approaching 0. And remember what the little plus sign means. It's 0 from the right-hand side. So therefore, what we're looking at is 1 over something really, really little. Because I can't say 0. If I say 0, that's undefined. But if I say we're approaching something very, very little, because it's the same graph here, but now we're approaching 0 from this side, our value isn't 0. We're not actually reaching 0. We're just getting really, really, really close to it, which means our graph is getting really, really big. It's going up, which means we're approaching, not in highlighter, which means we're approaching infinity, which therefore means we are diverging. Okay, so hopefully this is just a review. So hopefully this is going, I'm not going too fast for you. If so, pause it, rewind. Okay, so again, review, warm up, same concepts, just a different graph. So you'll see this one is e to the x or e to the negative x, just depending on the version of it in the problem. You may want to try pausing the video and see if you got these. Otherwise, here we go. Okay, so for this, once again, this is infinity. You can't write that, so I'm going to write just this is e to the negative something really, really big. Now, whenever I have a negative exponent, that's going to be 1 over e to the something really, really big. And 1 over something really, well, e to the really, really big is something really, really big. Because remember, e is just 2.718. So what we're talking about is 2.718 times 2.718 times 2.718 times 2.718 over and over and over and over. So that just gets gigantic. So therefore, 1 over something big is something really, really little, aka 0, which means it converges. I'm just going to start shorthanding this. Converge. Okay. For the next one, this one would be what? E to the something really, really big, but there's no negative exponent like that last problem, so I can't do anything with it. That just gets really, really big, which is the concept of infinity, which means it diverges. Okay. Next, and not least, we don't always just have to approach infinity. We can approach negative infinity if we wanted to. So we go ahead and substitute that in. That's what? E to the negative really, really big. So it's important to pay attention to that negative sign, because now we have that problem like we had in number 4, where 1 e to a negative exponent, that's 1 over e to that same really, really big exponent, which is 1 over something really, really big, which means we're getting something really, really small, 0, which means we converge. All right, so there's your warm-up. Go ahead and check out the next video, and we'll do the actual improper integrals.